Hello, and thank you for taking the time to look at this webinar today. We're going to look at the integrations between Vectra AI and Cybereason EDR. Obviously, hopefully you're all very aware that one of Gartner's recommendations is the SOC triad, which talks about SIM, EDR, and NDR. The Vectra solution here is the NDR part of that with a network detect and response. And what we're doing there is we're looking at all network traffic, whether it be cloud, on-prem, or in virtual environments, and we're looking for that attacker behavior with the environment, not just simple anomalies, as many other vendors have done, but actually looking for dedicated attacks in your network and following that across the kill chain. And obviously, with the Gartner recommendations, the great part of the integration is being able to see, not only do we see this host is infected, it's doing bad things, you need to deal with it, it's be able to then pivot or get other information directly from your EDR of choice. And in this case, Cybereason, you can really drill down and see what's going on. So on the Vectra dashboard here, you can see exactly what's going on. I can see how many critical hosts, high, medium, and lows I've got, what's changed within this time period with these numbers here, the key assets, the worst offenders in my environment. Now, what I can do though is I can quickly pivot into hosts, and I can go and look for a host that I know I've got a problem with, but it's also one that we've got a Cybereason client on. So if I bring up Leroy Brown, I can pivot into that. I can see it was a new host. I can see it's been doing some external remote access, some targeted recon. I can see the score is very high. It's something I probably want to deal with. As you can see, it's a VM machine, and we've got some information from that. But if I wanted to get a bit more context directly out of the Cybereason console, I can easily add in here a Cybereason tag, and I can ask for context. And if I hit the button there for context, straight away, the API in the background will talk to the Cybereason product and pull the information directly from it. So if I refresh this host now, you'll see all of these tags then being enriched with the OS version number, the machine name, the site it's from, the department it's from, all of the information you would expect to see. Really useful when you're trying to understand a little more depth in that. But you might also go, well, actually, I'm really concerned about this. I'd like to isolate it from the network. So I can go CR block, add a tag for that. Again, the back end of that, the APIs and the integration directly will go out and tell the Cybereason to block this host. Now, if I go and then look for Leroy in here, see I've got my Leroy Brown machine here. I can go and look at the information about this machine, and I can see already this machine is isolated. Now, my colleague from Cybereason will go into a bit more depth about what more you could do within here, but obviously you can see directly from the Vectra network detect and response, I've managed to isolate that machine directly from the network. Now, it might be that I fixed that, I've looked further into it. If I refresh this host again, you'll also see that there's a tag added for at the point we did this manual block and what we told to do. I can also go in here and say unblock, I want to remove the block directly from it. And again, the APIs, the integrations will deal with that automatically, and it'll remove it from the network. If I go back to the host in here, click on the information, you can see it's no longer being isolated. So it's really quick way that if you see in the Vectra solution this critical host that you need to go and do something with, you're concerned about it, you can not only enrich that host information with the information directly from Cybereason, you can also go and isolate that host directly from the network, while you may pivot into Cybereason and then investigate further as what's been going on. I'll let Cybereason talk a bit more in depth about how that works, but hopefully that's very useful. I will pass over now.
Thanks, David. So let's have a look at the Cybereason end of this information. So if we see here within our investigation or query screen, we can see the Leroy Brown machine, and then ask some questions against the endpoint itself, because Cybereason is pulling a lot of information from the endpoint itself, in effect metadata, that as an analyst, I can get a better look at what is the risk to not only this machine, but perhaps other machines and users in the environment. So using the Leroy Brown machine as a basis, let's just see what else is happening in the environment. So first of all, I want to see, which users have been logged into this machine. So we see a nice list there, not just logged in users, but also things like service accounts, etc. And then I can see in turn, okay, which processes have those users started or been involved with, not only on this machine, but on other machines and servers in my environment. Okay, so straight away here, we can see from a Cybereason end that we've actually tagged a lot of the data that we've collected in with this information here. So on the left, that means there's a malop, a high fidelity alert involved with this executable that we've picked up as running on an endpoint, and then suspicions against that as well. So straight away, the analyst has a nice guide point on what will potentially be malicious in this case. But I'm going to start off with an example down here. So something where we've picked up a suspicion around command.exe. And I'm going to click on here just to get some of the context that we're seeing here. So first of all, we can see from a hierarchy point of view, which user has actually run that session, and then also the parentage of this. In turn, I can see the children, so we'll go back to this in a second. There's, obviously something malicious around, as the name suggests, mimikatz.exe. It looks to be a credential theft attempt of some sort. But before I get into that, let's just go through some of the context that we have here. So we have a process timeline. So we're doing a lot of data analytics on the back end of all of this metadata that we're pulling from your entire environment, and then actually tagging it with, okay, when did we actually pick this up as being malicious? So where do we actually see this as being an infection? And then we actually tag the data with what we call suspicions and evidence. So all of that analytics that we're doing in the back end, we're not just triggering based upon one piece of information. We're looking for multiple touch points that in combination together look potentially malicious. So in this case, the actual file itself we're seeing is malicious, but then it's also running from temp. So this is a sign that, something is potentially malicious as well, but it's primarily around the file hash. As we scroll down here as well, we can see the command line. How was that ultimately that executable that's malicious? How was that run? So we can see a batch file here running it. Things like the process ID, start time, end time, things like that. But really the information here is here. We can see the child process being potentially malicious here. So within the UI, I can click on that for a better look. And then in turn, we get a different process timeline against this. But as we scroll down, conceptually, we get into, we've covered before, talking about the idea of a malop. So this is this high fidelity alert that we as Cybereason with our data analytics think that something bad is happening on this endpoint. So if I click on this, we can start to get into the alert screen itself. So description of what we think is malicious here. So it's actually fairly straightforward. It's based upon the file hash. So we've picked up a piece of malware. We can see the scope of the attack. So the machine, the affected users. So this UI is always clickable. We want to give the analyst as much context as possible to make a decision. Also, the process that we've seen as being malicious, if there was any network communications from the endpoint itself, a timeline. So, similar to the process timeline, but it's worth noting here as well, we can see that we've actually remediated this. So David covered the isolation of the machine, killing all of the network comms on the endpoint, apart from, from our viewpoint, it's all of the network comms apart from the encrypted connection from a sensor to a data analytics backend that remains, but we also have a remediation step. So because it's been remediated, this is grayed out, but this would give you the opportunity to actually, if that process had run, to actually kill the process, clean out the registry, things like that. So it's giving you a way contextually to actually see what is malicious on the endpoint and actually stop it from running. So closing the loop in effect.